Hi, this is Professor V.K. Patil and I welcome you to my video classes on basic electronics. In my last class, we have discussed what is Boolean algebra. In that, we have discussed what we mean by logic, what is truth table. Then we have discussed some laws of Boolean algebra. We have discussed the first law of Boolean algebra, which is complement law. Complement law, it states that the first law is complement law. In this we have discussed the complement of 0. The complement we can represent by a straight line on a variable or a value. The complement of a 0 is 1. Basically we can calculate the complement by performing 1's complement. Then complement of 1 is 0. In this rule also we have discussed complement of a complement, I will get a original variable, right? So here a complement, its complement, I will get a, right? So this is what we have discussed in complement law. Next we have discussed the OR law. In OR law we have discussed if I add a 0 to the variable, I will get a variable one. So anything added to the 0, I will get that value. So here again a, it can have two values, 0 and 1, and we have proved this particular law by considering the different values of a, that is 0 and 1. Then we have discussed a plus 1 is equal to 1. If I add plus 1, if I add 1 to the variable, I am going to get the result which is 1. This also we have proved by considering the different values of a, that is 0 and 1. Next we have discussed a plus a complement, which is equal to 1. If I add the complement of variable to the variable, I am going to get the result 1. This also you can prove by considering the different values of variable, that is 0 and 1. Next we have discussed a plus a. It won't come to a as in decimal algebra. Here in Boolean algebra we will get a plus a, which is equal to a. So this is all about the OR laws. Then we have discussed the AND laws. In AND laws we have discussed a dot 0. Basically dot is the operator, here plus is the operator, which is logical addition. Dot is a logical multiplication. A multiplied by 0, logically multiplied by 0, I am going to get the value 0. Almost same laws are here, but rather than a logical plus, now here we have logical multiplication. A dot 1, I am going to get a. A multiplied by a complement. A multiplied by a complement. What is the value I am going to get? I am going to get it as a 0. Right? And a multiplied by a, I am going to get a, not a square. So these are the laws what we have discussed in last class. Now we will see some other laws. The other laws what we are going to discuss are commutative law, associative law and distributive law. What this commutative law is? The commutative law, it allows us to interchange the position of variables in an expression. What it means? In that, let us say the first we will see, which is a plus b. It is nothing but logical addition of two variables, which can be written as b plus a. That is what the position of a and b in logical addition are permitted. That is nothing but the commutative law. So this commutative law is also true in logical multiplication also. Hence I can say A dot B is equal to B dot A. Now how to prove these relations? You need to prepare a table. Take A variable, then B. Then first complete the left hand side, where left hand side is nothing but A plus B. Then perform a right hand side B plus A and show that left hand side is equal to right hand side. Same for the second rule. This is the way how you can prove the different laws of Boolean algebra. So I will do it for one example. Let us say this one we are doing. A, it can have a different values 0 and 1. So first combination is 0 0 0 1 1 0 1. Okay. Now A plus B. A plus B, that is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. Similarly, now B plus A. B plus A is 0 plus 0, 1 plus 0, 0 plus 1, 1 plus 1. Now if you observe carefully, so this table is equivalent to this column. Hence I can say that this law is proved. Right? The next law is associative law. What this associative law it does? It allows us to removal of brackets in the equation and regrouping of the different terms. Right? So for example, A plus B plus C is equal to. Now what this equation is? It is Boolean expression. In this Boolean expression, the terms which are inside the bracket, they must be solved first. Right? So here B plus A, it must be done first and then it should be added with the logical value of A. Right? This is what this equation it states. This associative law, it allows us to remove this bracket. That is what? A plus B plus C. And again I can regroup A plus B plus C. Now right hand side it tells that first I can perform the logical addition of A and B and then I can add the result with the logical value of a C. This is nothing but associative law in logical addition. Same I can do it for a logical multiplication also. Right? So where I can say that A dot B dot C, which is equal to A dot B dot C, and I can make a group of A. This is nothing but the associative law. Next law is distributive law. So this distributive law, what it does? It allows us factoring and multiplying out the expressions. Let us say example. Now the first law is A dot B plus C. Now here I can do the multiplication to each and every variable which is present in a bracket. That is, so I can write this as A dot B plus A dot C. This is what I can remove the brackets or I can solve the brackets. This is permitted by using distributive law. Also, A plus BC, I can write this as A plus BC, I can write this as A plus B multiplied by A plus C. A plus B multiplied by A plus C. Here this is second law in distributive. Third law is A plus A complement B. A plus A complement B. It can be written as A plus B. It can be written as A plus B. So this is the distributive law. The next law what we are going to discuss is law of absorption and De Morgan's theorem. What is this law of absorption? The first law in law of absorption is A plus AB is equal to A. A plus AB is equal to A. Right? Second one, A dot A plus B. A dot A plus B. It is equal to A. Last one, A dot A complement B. A dot A complement B is equal to B. These are the law of absorption. Here some terms are absorbed. A plus AB is equal to A. A plus AB is equal to A. A dot A plus B is A. A dot A complement B is equal to B. The last one is De Morgan's theorem, and which is very essential. The first law of De Morgan's theorem is A plus B complement. What is this A plus B complement? Basically we have sum A plus B and its complement. That is nothing but complement of a sum is equal to product of complements. That is what? A complement or B complement. How do I can write? Complement of a sum is equal to product of complements. Is equal to product of complements. This is the first law of De Morgan's theorem. Second law, A dot B complement. What is this? It is nothing but the complement of a product. Complement of a product, I can write it as sum of complements, which is nothing but sum of complements. Here I can write this as complement of product is equal to sum of complements. So these are nothing but the laws of Boolean algebra. By using these laws of Boolean algebra, any given Boolean expression can be simplified. The simplification of a Boolean algebra, it means that I need to reduce the number of digital circuit required to implement the Boolean expression. It is not that I need to reduce simply the terms in the expression. It doesn't mean that simplification of a Boolean expression. Simplification of a Boolean expression means what? I need to reduce the hardware required to implement the Boolean expression. We will see the basic building blocks, that is basic hardware which is required to implement the Boolean expression in my next class. Till then, thank you.